So Jackson, why was your hand shaking during the prep for task 1? Here is a reenactment of task 1. First, we set our start point at the bottom left and set it to our desired direction. Next, we place down our obstacles accordingly and make any adjustments if needed by dragging it around the grid map. Then we can set which direction each obstacle is facing. Once done, we save the map and send the layout of the arena to the RPie. The RPie now sends back to us the shortest path route generated by the algorithm, and we reflect the path accurately on the app. Based on what image was recognized, the obstacle ID changes to the proper image ID.
The Raspberry Pi acts as the central hub connecting all key components of our robot car. A Wi-Fi connection links it to our PC running the image recognition model and the pathfinding algorithm. Simultaneously, it communicates with our Android tablet using Bluetooth over an RF COM channel, displaying a real-time obstacle map for user monitoring. For motion control, the RPie sends commands using the UART serial interface via USB connection to the STM microcontroller, which directly operates the motors and sensors. To efficiently manage these parallel data streams, we utilize multi-threading, assigning dedicated threads to handle inbound and outbound communication on each channel, ensuring responsive and stable robot operation.
Everyone look at me. They should look at ALVIN or me.
Just start whenever you're ready. Of all the things that could go wrong, it's the image recognition.
You'd think that if you took your own pictures, labeled everything yourself, wait many hours going through countless versions, and you'd get a good model. And you'd be right. But you only have yourself to blame for teaching it something you shouldn't have.
As for the algorithm, we first use Hamiltonian path planning to find the best order to visit obstacles. Starting from the robot's current position, we use methods of getting distance to choose the closest obstacle and then visit them one by one. Next, we use the hybrid A star to plan the smoothest path between each point, so it simulates car-like motion using gear and steering inputs, making it more realistic.
Sorry guys, the bullseye ID is on me.
So we're going to rerun the task.
But we got 5 out of 7, right?
No, got 3 out of 7 because we not into
Guys, Celeste just need to change one code, and I think it won't get the bullseye ID.
So after that happened in task 1, we did a full review.
For task 2, we implemented the infrared sensors and refined the gyroscope calibration since we had no retries left, so we could not risk getting disqualified. The most time-consuming part was actually troubleshooting. We tested the robot several times only to find out that our wire was broken, so we had to resolder everything. And at this point, we were confident that we were able to make it past task 2.